So what we got here is a universal shift register. So right now our two inputs are going to be these two right here. So this is going to be 1, 1, which is going to have a parallel load, which basically means our standard logic vector over here, which goes from 7 all the way down to 0. Since we have them all set as 1s, it's going to take each one, and right when we have, it's going to parallel load it once we press that clock, and it's going to do it, it's going to load the inputs into the respective outputs, which is an LED above each one of these switches. So if I press 1 clock, it just took all the 1s and loaded them in. So 1, 2, 3, 4, 5, 6, 7, 8. So that's our standard logic vector all the way down. So it's 8 1s. So what we can do with these opcodes is if we want to shift right or left. So if we want to shift right, we do 0, 1 is our basic opcode. That means when I press that clock again, if I just press it one time, it should shift the whole thing to the right, this whole vector to the right. So we should see a 0 be loaded in here because we're taking this whole vector and shifting it. So this guy is going to be going out, and they're going to replace this over here with a 0. So let's see if so there it is. So see, a 0 was loaded in, and it shifted the whole vector to the right. Now if we go back over here, instead we do 1, 0, that means it's going to shift the whole vector to the left. So what we're going to do now is our whole vector again is going from this 7 all the way down to 0. The moment we press this clock, it should shift it to the left once, if I just press it one time. So there it is, it shifted to the left one time, and there it has the 0 that was, just loaded because we moved the whole vector. That 0 is going to have, or that least significant bit is going to have a 0 now. So so we've had the parallel load in, and then we've shifted it to the right, we've shifted to the left. And so basically what will happen is if we want to reset the whole thing all at once, we could just clock this whole thing out and just keep on going until we shift the whole vector out. But if I go ahead and I do the parallel load back again, and I get all LEDs, we have set this reset up here. So if I hold down this reset, then right when I press this clock, it'll push that reset through, and it'll get rid of all the LEDs, just like that. So that's the parallel shift register.